Hello everyone, in this video I'm going to show you how the partition mesh operator works, and we're going to use it on a primitive cube and build something like a Borg cube so we can know more about this operator. So this is an experimental operator which splits the objects into several pieces using the topology or the faces. It uses the same randomization solver as random panels or random loop extrude to create the panel islands. So instead of creating the panel islands like you see here, this will instead be used to split the source mesh into different parts. The advantage being that you can then use more subdivision on that particular piece of object than you can compared to using it on the whole mesh. So for example, for this entire mesh, you can see that if I need to achieve the amount of small detail that I need for example, 24 subdivision, it's gonna be harder for me to achieve that because that level of subdivision would already introduce lag to the operation because of the how many phases are involved for the task. So, but if we, for example, separate this part here and use the same operation, so for the same subdivision, it's much lighter, and we can go to a higher subdivision than compared to using the entire mesh, because this part involves only a lower resolution count. So that's the idea of the partition mesh. We break up the source mesh so the subdivision becomes more manageable when using it to create more details. So we're going to use color random for the color of the meshes here. So its separate mesh is a different color, so we can see the separation more much better. So partition mesh, just the basic use random and radial. Okay, select the entire mesh or the entire faces. So this separates it into different objects based on the solver or random solver, and these separated objects have been parented to an object which is also a part of the source mesh from before. So to select the parent, you can just select an object from the group and shift G and then select the parent in the options, and there we go. This is the parent. Okay, so now we can use since we selected the faces before using the partition mesh, the result of the result of the operation, the faces are already the faces are already selected. So we can just go, for example, if we can use the non-destructive operation here, or the destructive using merge panel. So let's just try non-destructive. So you can see that I can achieve much higher subdivision than using the entire mesh. So let's just use 16. Then click on another object, then shift R to repeat the operation. So we can you can see that we have more details using the source mesh separated like this instead of using it whole. Okay, so this is the destructive operation, a non-destructive operation, which means that the source mesh is untouched. So let's just delete this and let's try the destructive method. And random loop extrude, this is purely non-destructive. You can also use it here. That and Shift R. Okay, that is how you can achieve the detail. But for non-destructive, using, for example, random panels or plate insets, plate inset is purely non-destructive. Random panels has, of course, an option for that, whether you use merge panel. If you use merge panel, then the operation is destructive, meaning that the randomization will be merged or fused to the source mesh, or the source mesh will be used for the randomization, not using another object. So we have a preset for that, square tapped merged, and just increase the resolution. So this is destructive. And then you can just select another piece and Shift R to repeat the action. If the Shift R repeat action is interrupted, you can just use the operator again and click one of these toggles, and then you can then reuse the redo operation on each of the object, separated objects. So the disadvantage of this is that you can use a different subdivision for each of the separated objects. So there some of the pieces may not have the same resolution as the other ones. So try and maintain a the same subdivision level when you're using it for the different islands. So you can leave this separated or merge them back together. You can just select a piece from the separated objects, which of course represents these the source mesh from before. Then Shift Q, if we hover over the partition mesh, you can see the tooltip that is saying randomly partition mesh or randomly split mesh, and then you can see that control click to merge, meaning that you have to press control in the keyboard. I think that's command on Mac or something. So control and then press the control click on the operator button while pressing on control, and it will merge the separated objects back together. So you have an option to do that. And you can achieve a much higher resolution and more randomized detail using this process. And but remember that you have to start with a high enough resolution for the source mesh to be split, because, for example, random panels, it creates the randomization can be created using by increasing the resolution using the subdivision right here. But the partition mesh doesn't do that. It has no subdivision property to increase the resolution. So your base mesh or source mesh should have enough resolution for it to be split apart into different objects. And you can still split a split object This will have its own parent on, nope, there we go. So this area here that we split will have this parent here, and this will be parented to this, which is the parent of all of the other split objects. And even if you select one of these, I think it will only unify that area. There we go. And then click and it will unify that area, but will not do it for this. To unify this, to include this in the unification, we need to select this. There we go. If you happen to partition the already partitioned part, then you have to select it and then another piece of the originally partitioned mesh, then you can include it in the merge operation. That makes sense. Okay, now let's use it to create the Borg cube. Okay, let's increase the resolution and radial. I mostly just use radial. I've introduced walk and the original solvers and path, but for me, I just use radial most of the time. And then just percent. You can use number for more accurate values for the minimum and maximum panel size or face count of each of the panel islands. But I'm just going to use radial and then something like 2%, 1%, no, 0%, and 2% as maximum. So panel seed, you can randomize the result of the randomization. You can do split and wrap. So split means the panel islands will be split in the area where the edges have a very sharp transition. Split. Okay. There we go. Or it can split on that area if possible. So let's just use wrap. Okay, now selecting a piece of the object. So even if you use the non-destructive, for example, if I use non-destructive, that you can still merge the source mesh after by selecting the source mesh and then um, merging using the same process mentioned before or I have described before. But in this case, let's just use I'm going to use the destructive operation. Square top merged and so this kind of resolution we cannot use on the original source mesh as a whole because it can result in too much of uh, too high res of a result and it will lag the operation. Selecting another piece, Shift R to repeat the action. Shift R, you can see that the operation is already lagging some area. Shift R. You can check the resolution. You can see here that I'm using wireframe to select to check out the resolution. You can do that. And that of course is useful even if you're not using the add-on and just using Blender normally. except for maybe really complicated models. So we're just walking around the mesh and repeating the operation. Don't worry about the resolution. You can always tone it down using decimation. Not decimation. Limit to solve. So we're just focused on the design right now, and we're going to deal with topology at the end. So, like I've said in my past videos, focus on design first. Design first before topology because it is much faster that way rather than constantly fixing your topology and resolution as you design. It's going to take you more. You're going to spend more time working when doing that instead of just focusing on one thing like uh, making the shapes right first instead of being too focused on the topology. We don't even have to, if the resulting design is too heavy and you want to keep the quad structure and not limit the solve, you can choose not to merge this. Okay, let's see if we missed a part of the separated islands or separated objects. Okay, where's the parent? Okay, we missed one here. Panels inset 50 parent. There we go. So you saw before that I selected this, and when I use this select similar or group parent, it selected nothing because this is the parent. So when I selected, for example, this one and shift G parent, it did its work and selected the parent. Okay, let's merge it. Let's merge this. Control click on the partition mesh operator. Press the control hotkey and then click on the operator. Um, yeah, there we go. We have our, oops, we missed one. Oops, random panels. Let's merge it. Okay. We're going to keep the quad structure. Um, with this kind of detail, there's avoid using random vertex color and using the limit sharp on this kind of resolution because this kind of high resolution freeze will freeze this the random vertex color operation if you use the sharp here because there's too much detail in the mesh, and this is going to assign a different vertex color on the mesh based on how sharp the edges are. So for this kind of number of resolution, don't use this option. You can't use any of this choices because it's a single object. It has no face islands, and again for select is there's too much of a resolution. So we're going to shade this. We're going to or procedurally shade this. We're going to use ambient occlusion or something like the geometry, the pointiness node or the ambient occlusion, pointiness node and the ambient occlusion to create a procedural texture for this using uh, using the grunt shader included in the add-on using this append materials operator here. Okay, so let's do that. Let's try and render this. What happened to this side? Okay, utility. I'm going to save this first. 1, 2, 3, 4, and shading up in materials, and then assign a material, our flow metal. Let's see the result. We're going to fix this, but first I'm going to change the HDRI. That was already fine, but I have randomized it again so that it's gone now. So yeah, selecting this. Be sure to have node wrangler on. Control Shift click on a node to see to preview its effects on the mesh. So 5 scale. Let's reduce the saturation. Copy this saturated color over this one here. Control C to copy and Control V to paste um, on the proper or similar property. Cavity mask. Let's try peaks. Okay. Make it thinner. 20. Edge mask. This is too big for this kind of supposedly giant object. So 0.005 and set the strength to 1. Scratches. You can do away with scratches or just use for this big of an object. Let's just use smaller scratches. The bigger the scale, the smaller the texture is, or the bigger the scale property, the smaller the texture will be. Okay, Control Shift click on the primary shader. Then we're going to use the pointiness node to create a texture effect. To get rid of this and geometry pointiness node. So pointiness nodes, the higher the resolution of your object, the better it will work, and this often works nicely with sculpted objects because of the high resolution. But if your model is comprised mostly of ingons, so ingons are really big faces, so that it will not work. This one will not work for that. But AO will work regardless of the resolution. AO just needs the how close the faces are to each other for it to work, and not use resolution like the pointiness node. We can control its intensity using the color ramp and experiment with the look right here. You can see You can see how it works. You can use this to create light effects, then multiply something over this, like J's placement, and then break this up to create a light effect. So we're going to actually, I'm going to show you how to do that. So we have the AO right here, multiplied to the, so there we go. Multiplied, the AO is multiplied to the pointiness node. So without the pointiness node, um, okay, without the pointiness node and with the pointiness node. So the clearly the details are more defined using this these effects. Okay, let's create the lights. You can use the lights UV, but we should have UV. It works with UV, so we should have UV this initially. But I think the initial UV of the cube is still there. There we go. This is the initial UV of the cube, so we don't have to do anything because this is just mostly angular. Okay, just increase the strength of the emission to make this work. Then adjust the inner scale to something higher to make the light smaller. Something like 800. So this kind of detail stretches could serve as far as the secondary detail, but if we need uh, tertiary detail, we can use textures for this. So let's use 1000 and make this less saturated. Go. So we're going to, like I said, have fun with the shader. Let's use green because it's just supposed to be a Borg cube. There we go. Okay, we're going to create an effect for the lights using the pointings node. So use a color mix node and use the add. Then add this. Then we're going to play around with the color ramp until we see the result that we want. Only this one here. So Control Shift click. You have to have Node Wrangler on for this to work. And we're going to use the white area to create the light. There we go. And okay, let's break this up using texture. Now I think I'm going to use a J's placement texture, but I think there's already a bunch of uh, other options you can use other than J's placement right now. So you can use those kinds of tools, or if you're just because you can't really I think sell what you create with J's placement. So this is just for exercise. You can use the texture for temporary effects until you find something that you can use without any limitation. Okay, so I'm going to use J's placement texture for this. But just to show you that you can use this kind of texture or a image texture to create this effect. So for this one, we're going to use multiply. We need to darken some areas. Okay. So create or copy the color here, Control C, go to this color stop here, which is the number one color stop, and then Control V on the um, what do you call it? Property. Okay, we need to reduce the size, so we're increasing the scale, make it smaller. Then something like that, just to break up the effect of these of the points in this node. There we go. And then get back to this, probably make this wider or use another. There we go. Okay, so that looks nice. It looks like there's a bunch of other details going on the surface of the model. So this effect looks nice, but I think we have to make the details smaller or the texture smaller, something like 15, to make the lights smaller as well, to make those effects smaller as well. Okay, and get back here and control the intensity. There we go. So subtlety. Okay, and I think we can also get rid of this and just use the this one. I don't know. Let's just use this. Okay. Uh, we have our Borg view. Okay, let's post this in render. Track lights and make empty and focus 100 focal length. To make objects bigger, you can use larger focal length. So we actually need to make the lights UV much smaller. 2000. There we go. Or 1 5000 or 1500. And I'm going to make the background of the HDRI appear, and also we're going to use sky. Just select something that works. Actually, I think the 120 millimeter is too much. Let's try 90 millimeters. There we go. We need to break up uh the um the outside and the outside profile. So we're going to do that. But first we need to select a better HDRI for the lighting. There we go. I think we can use this one. So there's the sun hitting this one, and there's the dark part. Okay. So I just need, I think I'm going to use random cells again to break up the outside profile or space. So cube, I'm not gonna use because of its resolution, I'm not going to use the high res source mesh from before for the random cells. Instead, I'm going to use just a primitive cube and then delete the cube afterwards. Probably scale it down just a bit like this, and random cells, this one here, and increase the resolution until the so increasing the resolution means the faces will be smaller, and then the sticks that are extruding out will be smaller as well. So 45, no, 100, 200, too much. It didn't. It doesn't crash. 0.05. Okay. There we go. Just small bump. Then we can increase the count full size to something like 300 maybe. There we go. So just to make something that protrudes out and breaks up the side profile here and there. Okay. Let's delete the cube. There we go. So if we need to make this smaller, we can just use Alt S. Alt S, press Shift, then drag the mouse. So by using Shift, you slow down the incrementation. Press S to make the process make the scaling process even. Okay, there we go. And then use the same material. So our flow metal, let's use it here as well. Our flow metal. Oops. Our flow metal. We need a tertiary detail. We have this. We have the primary shape, which is the cube. Secondary shape, which uses the geometric detail, and then geometric detail introduced using the partition mesh and random panels. But we need a bump texture here as well to introduce the tertiary detail. So instead of using J's placement, I'm just going to use Greeble Bake. Okay, Greeble Bake. Also partition this. Let's partition this. And there we go. Create the same details using the same process that we did before. It's not working. Okay, oh, what the? Why is it? That was strange. Okay, Shift R, Shift R, Shift R, Shift. So why don't I just make the operator work on multiple meshes, because that will be a bad idea and it will defeat the purpose of the partition mesh, because working for the operator to work on multiple meshes, it will defeat the purpose of separating the objects to make the subdivision more manageable. So by working on the multiple objects, basically made it work on a single object that has a lot of resolution. So okay, merge it, partition mesh, and then I think we don't have any. Okay, we have one. Okay, we missed two faces, but that's okay. Let's go to image editor to see the baked images. Let's go to Greeble Bake and select this object, bake origin. So the plane, this one here. Depth location is lowest geometry because we have a geometry that is extruded below the origin point, and normal, AO, and displacement. We're just going to use normal. Uh, maybe displacement. Yeah, normal then displacement. And leave this alone. Bake to last images, pack images so it doesn't get darkened out by Blender or erased. And then we're going to use 1024 to 048 and bake. Okay, this is the displacement. Don't worry about how it looks. It looks correctly. It looks correct. I mean, correctly. It looks bake normal, and this is our normal. This is our bake displacement. So in order to make the color brighter, you just need to adjust this distance or the brightness. So read. You can read. The online documentation for this is complete. So go ahead and read that. The link is in the preferences of the add-on or in the product page. And this is really I'm going to dedicate a uh, another video for Greeble Bake again, probably tomorrow, just to show you the its untapped power. Okay, going here and going to the shader. We're going to use the normal. So there's bump, 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 and we have bevel. And all we need to do, I'm going to create a file. So just select this, Control T to create this. Control T hat can only works with Node Wrangler. So Control T and then just the detach. So what I did there is just use this node because it has an empty out input node. Control T, I just use that to create this combination of nodes, then detach and bake normal. Okay, so bake normal color space should be non-color, and we need it to connect this effect to this to the effect of the bump, the bevel. So all we need to do to do that is normal map, color, and stroke, yeah, color here, and then connect this to the normal of the last vector node that is affecting the normal node of the principal shader. So that's it. Let's see how it works. Let's see if it works. Did it work? Of course it worked. It's just too big. Let's make the texture smaller. 20. Oh, there we go. It did work, but the detail is, yeah, it's too small. We need something to, because it's mostly just lines that are split and it doesn't really look correctly. Why doesn't it look correct? Image editor, bake normal. Okay, looks good. So one, okay, and 10. Oh, it doesn't look correctly on this side faces because these are not UV. Let's try object mapping. And for object mapping, you should use box projection. There we go. We should have less distortion on these areas, on those areas. Control Shift click. Now, in order for this detail to show up more, we're going to use the displacement color to the displacement to affect the color instead of using displacement. And then Control P. Actually, they need to be the same. They need to use the same mapping. So connect that to this. And here we're going to use multiply and use colorant to affect the intensity. And use bake displacement, should be non-color as well. Okay. I think we need to actually use displacement for this because the normal is not really working to bring out the detail because the model is supposedly too big. So, okay, let's still use this setup, but less so. And then we're going to use displacement instead. Okay, so this is the displacement vector displacement and connect it in the height and connect this to the displacement out mode output node to the displacement input node of the material output. Damn. Okay. Set this to something smaller like zero point 0.5 and mid level to 0. And in the material, in the settings, let's use displacement only for the displacement effect. So for the displacement effect, you can use bump, displacement only, or both. Yeah, I don't know why they have displacement and bump. Yeah, we can try it in the next videos. Okay, rendered. However, the displacement is reliant on topology. So yeah, you can see the mesh kind of just there's a bump. That's the displacement working, but there's not enough resolution for the displacement work. So just remember that you might not need to go into this the tertiary detail, especially if you have a really slow computer. So this will require a lot of memory. Let's increase the resolution by creating or adding a subdivision. Control 1. You can see that Blender is already struggling. And I'm using 4090 RTX and I think 64 gigabyte RAM, and you can see that it's already having trouble using even adding subdivision level 1 for to this kind of resolution. Okay, let's render this and see the effect of the displacement. Remember that you don't have to do this, and actually, yeah, I think the displacement will be too much. Okay, let's abandon that idea and let's just focus on this one. I wonder why the normal is, yeah, it's just displaying this it's just displaying those split lines. It has no height data. You know what, let's redo the bake again. Alt H. We need to make the details pop out more using just the normal. There we go. And partition mesh, random panels, increase the resolution. Okay. So we don't need to actually use depth or negative depth. And let's increase the thickness. There we go. You can try margin. Yeah. Um, no margin. Shift R. Repeat. Hopefully this will make those lines much more obvious. So the displacement would still work if you plan your subdivision or resolution. But I didn't plan my resolution, so yeah, can't use it. Even if I do have a high-end computer, still wouldn't use it. And bake to last images. So let's just replace the old one. And bake. Select origin. Select a bake origin. I think we don't have to reassign the textures anymore because we have already assigned it. Okay, so let's look at the texture at least. So this is the normal, and this is the displacement. Don't worry about how this is actually correct. How intense the color is or how dark. So this is correct. Don't worry about how dark it is. Okay, burnt normal and shader. Hide this and let's see the result. Hopefully it works. Yeah. There we go. I think we need to use constant. No. Constant is not working. Come on, constant. Nope. Should be linear. There you go. And let's just dampen the effect. Too much. Okay, now we have our tertiary detail, but not too much. We can appreciate. You can what you call this? You can appreciate the detail more if you look closely at the model, but with far away render ranges, you can actually really see it anymore. So for this detail, again, You can make it larger by decreasing the scale value like that. Okay, so that um, you can see that the lines are more prominent because we have widened the thickness of the panels. It's really good. And point eight, you can just modify the look of the shader just by playing around with the values. Okay, there you go. Where's our track lights? Make it again focus. Okay, let's try a studio. Excuse me. Studio um, HDRI. And make the background darker to get rid of the textures. So we have like we're mimicking open space in the region. There we go. So this is our Borg cube. So there's it's subtle, but I think we can see the tertiary details much better now. Let's increase the f stop because this is supposed to be a big object, and we don't have to use a lot of depth of field. Okay, so you can see the tertiary detail that we just baked using Greeble Bake. As you get closer, the more it becomes prominent and more obvious. And one thing about it is that since we're not using displacement anymore or considering displacement, we can get rid of this resolution by limit dissolve. So just the default 5 degree could work, but let's try 2.5. There we go. And triangulate, Control T. And now you can see the don't worry about the this ones here, the shading errors. And but we have modeled the effect of the we have modeled or softened the effect of the point finish node because we get rid of the resolution. So like I said before, this works better with high resolution objects, and with in guns it does this, but we can still live with this. I think it's much better this way. I guess. So, let's try changing the color. How about constant? No, constant is okay. Not constant. So just linear. Okay, so here you go, our Borg cube. So with this light enough resolution, you can just save this to your asset browser and just drag it on a scene and render it. So a good thing about this is that because we are using geometry, you can render it closer to the camera, and it will still have these details like this extruded details, and it's actually lighter than using displacement, because with displacement you need to use increased resolution using subdivision for the displacement texture to actually display and work effectively. So with this method, although it is less superior than actually using high-end displacement, it will, of course, with enough with skillful maneuvering, you can achieve the same result using this technique. Okay, what's that? Is that the sun? I think we can get rid of that using contrast zero. There we go. So this only affects the display of the look of the HDRI and not its its effects on the objects. Okay, so we have our Borg cube. Should I? What if we change this to purple? Ooh, it's like so. Purple is like the color of chaos or cosmic terror or eldritch that is in space. But green is Borg. Okay, so that is our Borg cube, and that is how to operate partition mesh. I will create another video using partition mesh to model a another some kind of portal device that is, of course, using a cylindrical base mesh instead of just being a cube. Okay, so yeah. So that will be it for this video. If you have any questions, use the comment section or the links in the description. Be sure to subscribe if you're using the add-ons or just learning Blender to learn more about the add-on and other stuff. And of course, don't forget to share the video so it will help me a lot during these trying times. And yeah, so thanks for watching and have a nice day.